Hey guys, welcome to Safi Mixed. I want to solve this trigonometric expression for finding the value of theta. That is, we have given p sine theta plus q cos theta equals r, and we want to find the value of theta from this trigonometric relation. So in the present form, that is quite impossible. For example, if I divide this equation with cos theta, I can make this tangent theta. This would be independent of theta, but this term would become theta dependent. That is, there will be always two terms that contain theta, and we are unable to factorize this equation in a way that to isolate theta to one side of the equation. So we do that by using another trigonometric trick, that is, I redefine P and Q in terms of two other parameters such that the parameters can be reproduced in terms of P and Q, and then we can solve it. For example, I can define P equals S time cos phi and Q equals S times sine phi. Okay, where S and phi are two other parameters. However, these parameters are exactly expressible in terms of P and Q. That is, though we are introducing two other parameters, but we can replace these parameters back with P and Q. For example, if I divide this one equation, let me call this equation A and this equation B. What if I divide equation B with equation A? I get Q divided by P equals S sine phi divided by S cos phi. S cancelled with S, and this is tangent phi, so I can write this as tangent phi. This allows me to write phi equals tangent inverse into Q divided by P. That is, the parameter phi is in fact redefinable in terms of Q and P. So this is not a new parameter. It is again in terms of the given parameters of the equation. So I call this equation C. Now, if I square equation A and B and then add them with each other, I can write P squared plus Q squared, A squared cos phi, A squared sine phi, so I can take A squared common, and I can write cos squared phi plus sine squared phi. This is 1, so we are left with S equals P squared plus Q squared square root. I call this equation D. Again, we see that S is not in fact a parameter from outside, rather S is defined in terms of the given parameters of the equation. So with these two choices of the parameters, we can now find the value of theta from this equation. So what I do, I replace the values of P and Q in this equation, and that gives me for P, I write is cos phi into sine theta plus, for Q I will write this thing is sine phi plus cos theta, and the whole of them equal 1. I write equals R. I write that over here. Now this is not plus, this is multiplied, so I write this as cos theta. Now I can take S common from these two terms to write this S into cos phi sine theta sine phi cos theta equals R. And from the trigonometric relation of sine of two angles, we know that this thing is in fact equal to sine of phi plus theta. That is, I can write, and I'm taking S to this side of the equation, and this, the term inside, the two terms inside the brackets, then reduce to a single term in the form sine of theta plus phi equals R divided by S. Or taking the inverse of this would leave me with theta plus phi equals sine inverse r divided by s. And from this I can write theta equals sine inverse r divided by s minus phi. And if I substitute the values from equation C in D, I can express the value of theta in terms of the given parameter. So I write theta equals sine inverse into r, and for s I write p squared plus q squared square root and minus phi, and for phi I can write tangent inverse q by p. So this equation gave us the value of theta in terms of the parameters of the given equation. So this way we can find the value of theta, or we can isolate theta from this equation. And thanks for watching.